Now, this illustration deals with standard Ampere ratings, the standard Ampere ratings, in accordance with NEC 240.6a and Table 240.6a. At this time, I want to take just a little time here to talk to you about 240.6a. Now, I know that experienced electricians and designers and engineers and contractors know this, but in 240.6a, you have those small fuses ratings of 1, 3, 6, 10. You have permission to use any size protected device that the manufacturer rates that the equipment can accept. But when we want the standard sizes that are listed for our use, then 240.6a refers the use of Table 240.6a. Now, kind of keep that in mind. Now, let's review first, what are the terminals of this equipment? Well, when we review the illustration, we have a 75-degree C terminals at the equipment. 110.14 C1A would actually rule here because the overcurrent device in the equipment is 100 amps or less in rating. Now, the load that we have there is 64 amps. 240.3 protects the equipment for the overcurrent device. 240.4, remember, if you reviewed this presentation, protects the conductor. So now let's review this number 4 conductor, size from 210.19A1A, and we're sizing the overcurrent device to protect the conductors, 240.4, plus protect the equipment in 240.3. So let's perform 240.5a and the boxed in information, starting with step 1. We will enforce and apply 210.19A1A as well as 210.20a. One is for the conductor, one is for the overcurrent device. So the 125% for, say, a continuous load, when we do our math, 125% times 64 is 80 amp. Now we have to determine, is that a standard overcurrent device? So when we review our standard overcurrent devices is referenced from 240.3 and 240.4b as our sections, but we select this standard size overcurrent device that's listed now in the table, in Table 240.6a. 80 amps, okay, that's it. Now the size of the overcurrent protection device is 80 amps. Now we have to select a conductor that will supply 80 amps. So going to Table 310.16, a number 4 conductor is good for 85 amps in the 75-degree C column. And notice the 80 amp overcurrent device would protect the number 4 conductor and the equipment. But if you had maybe a motor load or something there and you wanted to round up to the next size, could you do that? You could only do that in 240.4b based upon the ampacity of the conductor, number 4, which is 85 amps. You could move up to 90 if you had a motor starting and you needed to round it up and get the full benefit of the 3 times rating of a circuit breaker. And it would also take care of your conductor. But you might not have the overload protection that you needed, so you may need a second stage of protection to protect the equipment as well as the conductor. But notice you can round up. That's all 240.4b is saying. If you have 800 amp or less overcurrent device, you can round up above the ampacity of the conductor. And most inspectors says, yeah, you can even round up if, say that come up to 78 amp, 125% of 64. Now I'm just saying what if. Then see, you could round that on up to an 80 amp device. So keep this in mind. that's what this figure 9-16 is illustrating. How do we protect the conductor and the equipment as required by 240.3 and 240.4? So you review, do you need a second stage of protection? Or you'd say, no, I don't. I can round that up and I'm still going to have the protection I need for the equipment and the conductor, then round it up. But if that's not the case, remember, exceeding the 125%, in most cases, you're not going to have overload protection. You'll have short circuit, ground fault protection, and the size device to let the equipment operate. But you might not have overload protection, and you want to keep this in mind.